In this video, we will look at relative frequency graphs. The graphs we've looked at so far show frequencies in terms of raw data. Now we look at turning the distributions we've been using into relative frequency graphs, which use distributions based on proportions. Graphs of relative frequencies are used when the proportion of data values that fall into a given class is more important than the actual numbers of data values in that class. If you wanted the age distributions of adults, if you wanted to study the age distributions of adults in two cities, say Galesburg and Chicago, you would use relative frequency distribution, since the number of people in each city is different. Chicago's got a lot more people than we have here in Galesburg. Actual frequencies tell you little, but a relative frequency distribution can tell you a great deal, because we can look at the percentages of people in certain classes as opposed to the exact numbers of people in those classes. To convert a frequency into a proportion, we divide the frequency by the number of frequencies. That should be the number of observations. The sum of the relative frequencies will always be 1. We use the same sorts of graphs for relative frequencies, but the values on the y-axis are in terms of proportions. So for example, we'll look at the ages of state governors. We'll construct a histogram, frequency polygon, and ogive using relative frequencies for the distribution shown. Here are our class boundaries from 42.5 to 47.5 years, 47.5 to 52.5 years, and so on, and our frequencies 4, 4, 11, 14, 9, 5, and 3. This is a grouped distribution using the ages of the governors of each US state at the time that the book was being written. So now we convert each frequency to a proportion by dividing the frequency for each class by the total number of observations. For example, for the class 42.5 to 47.5, the frequency is 4, and there are 50 total observations. The proportion for this class would be 4 divided by 50 equals 0.08. And we'll also use this opportunity to calculate midpoints for later use. So here is that table. Next, we find the cumulative relative frequencies. To do this, we just add the frequencies in each class to the frequency of the preceding class. 0.00 plus 0.08 equals 0.08. 0.08 plus 0.08 is 0.16. And I wrote that wrong too, sorry, it's late on Sunday and I'm tired. There we go. So that should just be 0.16. And here is the cumulative relative frequency table. Now we draw each graph as shown earlier in the section. So here is our histogram. Here's our frequency polygon. And down here is our ogive.